few problems in my compressor. The valve that controls the airflow from the tank to the pipeline, which I usually shut off every day if I'm not using it to keep the air in the tank, because it slowly leaks and I don't know where it's leaking from. So every night when I've finished with the compressor, I'll switch the valve off, and when I did that yesterday, the top of the valve snapped off because it's a plastic moulding onto a brass valve stem. So today's project is to replace the plastic moulding with another piece of brass and machine it to fit the valve stem. So let's go into the workshop and see how we do it. This is a valve for my compressor that turns the air on and off. I've been using it for a long time, 20 years I would say, and finally the plastic around the end has snapped. So what I want to do today is use this piece of brass, which is 3/8. You can see it's all bashed and been used as a piece of brass to tap jobs through. And you see the brass is all damaged and bent, and what I'm hoping to do is machine a radius on each end, or a dome, it's not important. Machine a flat, put a slot in there, so the end of this valve will go into the slot and give me a new handle. So we'll start off on the lathe. I think I'll put my collets on to hold this. The first job is to remove the chuck and fit my collet. So piece of wood on the bed, chuck key. Now some people use the chuck key, but the problem with using the chuck key to take your chuck off, you could snap off the end of the key if it's a small square on the end. So I can open the jaws, just put a piece of steel in there, put the lock on, you'll see that's already come undone. Take the chuck off, put my thread protector on. So the way I fit the collet, ER20 collet holding the brass. This is a number 3 Morse taper which goes into the end. Use my taper cleaner to clean the taper. This is just a steel bar with a thread on each end. The thread fits onto that. The collet holder goes in. Then from the other side of the headstock, I'll push the steel bar through and tighten it up on the holder. Open the back of the headstock, the gearbox. You can see the drawbars there. So what I do now is put this bush on, which centralises the drawbar, and a nut. Now as I tighten this nut up, it pulls the collet holder into the spindle. I don't need to tighten it a lot, just till it starts to move, and I know that's pulled the collet in sufficient enough. And the mechanics would notice that this nut is a wheel nut off a car. Close the door because this has interlock on it and the machine won't work with the door open. Take the block off. I'll just tighten this up. See how that runs. Speed it up. Just zero the X so I know where my tool is now. I'll change that the other way, turn that around and machine the other end. Now I need another collet, a bit smaller. That may do it. It's the next size down. It's still a bit loose, so see if it tightens up on that. Now as I've set my dial to 0, I can come back in and this end to the same diameter as the other end. Should be the same diameter as the other end. I'm not bothered about this small hole in the end, so what I'll do now is try and just radius the corner off. There's some rattling going on down here. I'll tighten the belt up a bit. Undo the collet and turn the part round. And then machine a radius on this end. Just missed a little bit there. So we've just got a piece of brass with a radius on each end. It doesn't matter the size, it's just so it's comfortable to hold. The next thing I need to do, machine a slot that this will go into in the middle. So to do that we'll go over to the mill. The width of this is 2.5 mil, and I've fitted a 3mm cutter. What I want to do is go down into the brass 4.5 mil deep and then form a slot 6 mil. I've set the cutter on centre, in the centre of the jaws and in the centre of the piece. So we'll go down 4 mil. So I need to make the slot length, I need to make that about 6mm. So that's a 3 mil diameter, so I need to go 1.5mm each side. I'll move it 1.5 mil, which is about there. And that should have a slot in there now. I think it's just a square on the edge, the sharp edges on the edge. So that's what we have so far. Now I've just put that in the vise to hold it between two pieces of aluminium to stop it getting damaged. I've just filed the little radius on the edges so it will now fit. And what I need to do is solder that into position so it's fixed. I've taken the O-ring off because I don't want to damage the O-ring. And I've made sure that the nut will go over, so I don't need to have the nut on, because it will fit from this side, then the O-ring will go on. First thing I need to do is this, because I've just machined it, it is clean. Just putting some flux, soldering flux on each side, and I'll fit that in to position where I need it. This is ordinary solder, nothing special. Heat this up. Feed the solder around till it goes round, forms a nice fillet. Let that cool down. It's cooled down now. and take it out of the vise. You can see there's a nice bead of solder all the way around, so I can put the nut and the O-ring back on. There we go, the nut's back on and the O-ring's on, so now we can fit this on back onto the compressor, see how it works. This fits in there, screws in, the nut goes on there, it should screw right in. Some air in the compressor. Turn that on. You can see the pipes moving, the air's in the pipe. Turn it off. On. Off. Oh well, that's another repair job done. Hope that was interesting, hope you enjoyed it, and we'll see you next time on Enots Engineering.